When you look up at the sky on a clear night, it's easy to feel like you're staring into a giant empty void peppered with some distant stars. But the truth is, those stars are really just the front porch. Once you step beyond our solar system, you'll run into a cosmic hierarchy so massive, it basically breaks the human brain. I'm Mike with List 25, and these are the 25 largest structures in the universe. 25. The Tarantula Nebula. If we want to talk about truly massive, we have to start at the beginning, the places where stars are actually born. Tucked away about 170,000 light years away from us in the large Magellanic Cloud, the Tarantula Nebula is the undisputed heavyweight champion of star-forming regions in our local neighborhood. Spanning roughly 600 light years, it's so bright that if it were as close to us as the famous Orion Nebula, it would cast shadows on Earth at night. It serves as a high-energy laboratory for astronomers, showing us the chaotic, violent processes that create massive stars, providing a glimpse into the building blocks that eventually form the larger structures on our list. 24. The Milky Way Galaxy. The Milky Way is a barred spiral galaxy containing between 100 and 400 billion stars, stretching approximately 100,000 to 200,000 light years across. It's hard to grasp the scale of our home until you realize that even at the speed of light, it would take you 200 millennia just to cross it. Yet, in the grand cosmic perspective, the Milky Way is just one of the trillions of galaxies, a single atom in a much larger biological-like web of matter. 23. IC 1101. Located at the center of the Able 2029 galaxy cluster, Index Catalog, IC 1101 is one of the largest known galaxies in the observable universe. It spans an incredible 5 million light years, making it about 60 times the size of the Milky Way. If IC 1101 were placed where our galaxy is today, it would swallow up the Andromeda Galaxy and everything in between. Most of its mass comes from a literal sea of stars and dark matter, illustrating how gravity can pull thousands of smaller galaxies together to create a single bloated elliptical giant. 22. The Local Group. Galaxies rarely exist in isolation. They tend to huddle together in cosmic neighborhoods. The Local Group is our immediate small town in the universe, a collection of more than 50 galaxies, including the Milky Way, Andromeda, and the Triangulum Galaxy. Spanning about 10 million light years, the Local Group is held together by the mutual gravity of its members. It represents the first level of large-scale structure, where gravity has successfully overcome the expansion of the universe, keeping these galaxies tethered to one another in a slow, multi-billion-year dance. 21. The Sculptor Wall. Once we move beyond individual groups, we begin to see the large-scale structure of the universe take shape in the form of galaxy filaments, or walls. The Sculptor Wall is a massive superstructure of galaxies, a literal wall of matter stretching approximately 250 million light years. It's one of the closest structures to the Milky Way, yet it was only identified relatively recently because it's so vast that it's difficult to see the forest for the trees. It also acts as a cosmic boundary, marking the transition from local neighborhoods into the sprawling, interconnected filaments that define the rest of our list. 20. The Great Attractor. Once we look past the visible walls of galaxies, we encounter mysterious forces that suggest even larger structures are at play. The Great Attractor is a gravitational anomaly located in intergalactic space at the center of the Laniakea Supercluster. It's so massive that it's currently pulling the Milky Way and hundreds of thousands of other galaxies toward it at a staggering velocity of about 600 kilometers per second. Spanning roughly 300 million light years, it isn't a single object you can see with the telescope, but rather a concentrated region of mass that acts like a cosmic drain. Astronomers struggled for decades to identify what it was because it sits in the zone of avoidance, a region of the sky obscured by the gas and dust of our own galaxy. Its existence reveals that our cosmic neighborhood isn't just floating aimlessly. It's part of a directed, massive flow of matter governed by a source of gravity we are only beginning to map. 19. The Perseus-Pisces Supercluster. Returning to the scaffolding of matter, we find the Perseus-Pisces Supercluster, one of the largest known structures in the sky. Stretching over 300 million light years, this chain of galaxy clusters forms a massive, dense filament that borders a great void. It's one of two dominant concentrations of galaxies in our nearby universe, acting as a massive spine in the cosmic web. What makes this structure particularly fascinating is its density. It contains over 1,000 galaxies and is thousands of times more massive than the Milky Way. When we observe this supercluster, we're looking at a snapshot of the universe's large-scale structure, where gravity has spent billions of years pulling matter out of the voids and into long, thin threads. It represents the midpoint of our list, a scale where individual galaxies are no longer the focus, replaced by the grand architecture of the cosmic web. 18. The Boötes Void. We now come to the Great Nothing, the Boötes Void. While most of our list focuses on massive walls of matter, the Boötes Void is a structure defined by its terrifying emptiness. Spanning roughly 330 million light-years in diameter, it's a nearly spherical hole in the universe. To put its emptiness into perspective, if the Milky Way were in the center of the Boötes Void, we wouldn't have known other galaxies existed until the 60s, because the nearest ones would be too far away to easily see. Astronomers have found only a handful of galaxies inside this vast expanse, roughly one every 10 million light-years. The existence of such a giant empty bubble is a crucial piece of the cosmic puzzle. It shows how gravity has spent 13.8 billion years pulling matter away from low-density regions and piling it into the walls and filaments I've been discussing, leaving behind these hauntingly silent abysses. 17. The Coma Supercluster. Located near the North Galactic Pole, the Coma Supercluster is a massive, nearly spherical forest of galaxies that spans roughly 350 million light-years. At its center are two monster clusters, Coma and Leo, which pack in thousands of galaxies. This spot is a legend in astronomy because it's where Fritz Zwicky first realized the math was broken. He saw galaxies moving so fast they should have flown apart, but something was holding them in. That was our first real clue that dark matter exists. The Coma Supercluster is so massive that it basically anchors the Great Wall, which I'll get to soon. It's a chaotic high-speed hub of collisions and mergers, proving the universe is really just a violent living tapestry of gas and stars held together by an invisible dark matter skeleton. 16. The Eridanus Supervoid. While we have been focused on where the matter is concentrated, some of the largest structures in the universe are defined by where matter is missing. Take the Eridanus Supervoid, often called the CMB, Cosmic Microwave Background, cold spot. It's this mind-blowing gap in space, nearly 1 billion light-years wide, with way fewer galaxies than you'd expect to find. We first spotted it as a weirdly cold patch in the Big Bang's afterglow. This hole is so massive that it actually stumps scientists. Honestly, gravity shouldn't have had enough time since the start of everything to clear out a space that huge. Whether it's just a weird coincidence or proof of some new physics we don't understand yet, the Eridanus Supervoid is a pretty chilling reminder. It shows us that the massive silent gaps between the stars are just as important to the story of the cosmos as the stars and galaxies themselves. 15. The Laniakea Supercluster. While we often think of the Milky Way as our home, it's actually just a tiny suburb within the sprawling metropolis of the Laniakea Supercluster. The name Laniakea means immense of heaven in Hawaiian, and for good reason. This structure spans 520 million light-years and contains the mass of 100 quadrillion suns. The defining characteristics of Laniakea is that it isn't defined by just looking at where galaxies are, but by mapping their movement. By studying the peculiar velocities of 100,000 galaxies, astronomers discovered that they're all flowing inward toward a shared gravitational center. This defines Laniakea as a distinct watershed in space. Everything within its boundaries is gravitationally bound to the same density, while galaxies just outside its border are flowing toward a different cosmic neighbor. 14. The Shapley Supercluster. If Laniakea is our home metropolis, the Shapley Supercluster is the neighboring megacity that exerts a massive influence on everything around it. Located approximately 650 million light-years away, it's the largest concentration of matter in our nearby universe. It's so incredibly dense with galaxies that its gravitational pull is actually responsible for much of the Milky Way's motion through space. Discovered in its early form by Harlow Shapley in the 30s, This structure serves as a reminder that gravity is a long-range architect. Even across hundreds of millions of light years, the sheer mass of thousands of galaxy clusters huddling together can tug on our home galaxy. 13. The Ho'oleilana Bubble. While many structures on our list are long, thin filaments, the Ho'oleilana Bubble, discovered in 2023, represents a different kind of cosmic giant. Stretching nearly 1 billion light-years in diameter, this structure is a massive spherical shell of galaxies that looks like a literal bubble in space. Its name comes from the Hawaiian creation chant, Kumulipo, referring to a murmur of awakening, which is fitting because astronomers believe this bubble is a fossil from the very beginning of time. It's a preserved remnant of baryon acoustic oscillations, essentially giant sound waves that rippled through the hot plasma of the early universe. As the universe cooled, these ripples froze in place, leaving behind these hollow shells of galaxies. Ho'oleilana is the first time we've seen such a shell so clearly, and its existence gives us a physical map of the sounds that rang out just moments after the Big Bang. 12. The Boss Great Wall. If the Ho'oleilana bubble is a hollow shell, the Boss Great Wall is the solid, towering skyscraper of the deep universe. Spanning approximately 1 billion light-years and containing the mass of 10,000 Milky Ways, this structure was identified by the Baryon Oscillation Spectroscopic Survey, or BOSS. It consists of 4 massive superclusters connected by thick bridges of galaxies and gas. What sets the Boss Great Wall apart is its incredible density. It's significantly more massive than the Sloan Great Wall, which I'll get to later. It serves as a dense hub in the cosmic web, a place where gravity has successfully overcome the expansion of the universe to pack thousands of galaxies into a single contiguous complex. Observing this wall is like looking at the backbone of our section of universe, a structure so heavy that it warps the very path of light traveling past it. 11. The Pisces-Cetus Supercluster Complex. While some structures are mysterious rings or arcs, others are massive, sprawling networks of filaments. The Pisces-Cetus Supercluster Complex is one of the largest filamentary structures ever mapped. It's a massive galaxy filament that includes the Laniakea Supercluster, our home, as just one of its many components. Stretching roughly 1 billion light-years in length and 150 million light-years in width, it's a dense ribbon of matter that contains about 60 different superclusters. This structure is a perfect example of the cosmic web at its most complex. It shows that even something as massive as Laniakea is just a single link in a chain that spans a significant portion of the sky. 10. The South Pole Wall. One of the most recent and surprising additions to the map of the cosmos is the South Pole Wall. Announced in 2020, this is a colossal curtain of galaxies that spans 1.37 billion light-years. Despite being relatively close to us, only 500 million light-years away, it remained hidden for decades because it's tucked directly behind the bright crowded disk of the Milky Way. Astronomers finally found it by tracking the movement of galaxies, noticing they were all being pulled toward a massive invisible structure at the celestial South Pole. The South Pole Wall is comparable in size to the famous Sloan Great Wall, yet it is significantly closer, showing us that even in our own cosmic backyard, there are still billion light-year long giants waiting to be discovered. 9. The Sloan Great Wall. For nearly a decade, the Sloan Great Wall held the title of the largest known structure in the universe, and its scale remains difficult to wrap the human mind around. Stretching 1.37 billion light-years in length, this cosmic filament is a massive wall of galaxies that looks like a long, thin thread when viewed on a map of the large-scale universe. It was discovered in 2003 using data from the Sloan Digital Sky Survey, a project that sought to map the positions of hundreds of millions of galaxies. The wall is not a single solid object, but a massive arrangement of superclusters linked together by gravity. At this scale, we begin to see the honeycomb structure of the universe, where vast, empty bubbles, voids, are walled in by these immense stretches of matter. It represents a transition point on our list. We are no longer talking about groups of things, but rather the very scaffolding upon which the universe is built. 8. The Quipu Filament. Coming in at number 8 is a structure that made headlines in early 2025, the Quipu Filament. Named after the ancient Incan talking knots, this is a colossal cosmic thread stretching a shocking 1.37 billion light-years. While its length is comparable to the Sloan Great Wall, its mass is what truly earns it this high ranking. It's estimated to contain over 200 quadrillion solar masses, making it one of the most concentrated rivers of matter ever found. Discovered using X-ray data from the Classics project, Quipu acts as a massive bridge connecting several distant superclusters. Astronomers were stunned to find that this one filament contains roughly 25% of the total matter in its observed region of space. Its discovery has forced a reevaluation of how much dark matter is actually hidden in these long, thin threads, as Quipu is far heavier than any current computer model predicted a filament of its age should be. 7. The Clowes-Campusano LQG. The Clowes-Campusano LQG, or Large Quasar Group, deserves its place in the top 10 due to its role in redefining cosmic boundaries. Comprising 34 quasars and stretching over 2 billion light-years, it was the first structure ever discovered that truly broke the scale of homogeneity, the theoretical limit where the universe should become a smooth, featureless soup. Its existence suggests that the universe isn't just a collection of random dots, but is organized into massive, elongated cities of light. Astronomers view this group as a prehistoric relic. Because it's billions of light years away, we're seeing it as it was billions of years ago. It stands as evidence that even shortly after the Big Bang, gravity was already working on a scale so vast that it was creating structures larger than what modern physics says should be possible. 6. The U1.11 LQG. Coming in at number 6 is the U1.11 LQG, another titan made of supermassive black hole-powered galactic cores. Located in the constellation Leo, this group consists of 38 quasars and spans a mind-blowing 2.5 billion light-years. To give you an idea of its scale, if you were to travel across it at the speed of light, civilizations would rise and fall, stars would die, and entire planets would be born before you reach the other side. U1.11 is part of a new class of structures discovered in the last 2 decades that consistently violate the expected smoothness of the universe. It's so massive that it exerts a gravitational force over its entire region of space, acting as a huge anchor for the clumpy distribution of matter in the early universe. Its existence convinces scientists to ask if our understanding of the Big Bang's expansion is missing huge amounts of information on how such large-scale seeds of matter were planted. 5. The Huge-LQG. Pushing the boundaries of what we thought was physically impossible, the Huge-LQG is a structure that forces us to rethink the laws of cosmology. This is a collection of 73 quasars that spans an astonishing 4 billion light-years. Its discovery in 2013 sent shockwaves through the scientific community because it appears to violate the whole cosmological principle. This principle suggests that at scales larger than about 1.2 billion light-years, the universe should look uniform and smooth. The Huge-LQG is nearly 4 times that size. Its existence suggests that those early universes might have had massive clumps of energy and matter that we still don't fully understand. It stands as the celestial titan, a structure so long that it would take light 4 billion years just to travel from one end to the other, making it a relic of an era when the universe was much younger and more chaotic. 4. The Giant GRB Ring. One of the most mysterious entries on our list isn't seen through visible light, but through the most violent explosions in the cosmos, gamma ray bursts, or GRBs. The Giant GRB Ring is a structure identified by the distribution of 9 specific GRBs that appear to form a massive circle in the sky. Spanning roughly 5.6 billion light-years in diameter, this ring is so large that there is only a 1 in 20,000 chance of it occurring by random coincidence. Astronomers believe these bursts are tracing out a massive hidden scaffolding of galaxies and dark matter that we cannot otherwise see. Much like the Huge-LQG, the Giant GRB Ring challenges the fundamental assumption that the universe is smooth at large scales. If this ring truly represents a single connected structure of matter, it suggests that the early universe was capable of organizing energy on a scale that our current computer simulations still struggle to replicate. 3. The Hercules-Corona Borealis Great Wall. For over a decade, this has been the undisputed heavyweight champion of the cosmic web. The Hercules-Corona Borealis Great Wall is a gargantuan filament of galaxies that spans a surprising 10 billion light-years in length. To put that into perspective, the observable universe is roughly 93 billion light-years wide, meaning this single structure takes up more than 10% of the entire diameter of everything we can possibly see. Discovered in 2013, its 10 billion light-year size creates a fascinating paradox. The front of the wall that we see is 10 billion years younger than the back of the wall. Its existence is a major headache for theorists, as there hasn't been enough time since the Big Bang, 13.8 billion years, for gravity to move matter across such vast distances to form a single connected structure. It remains the ultimate mystery of large-scale astronomy. 2. The cosmic web. While the Hercules-Corona Borealis wall is a single thread, the second largest structure is the web itself. The cosmic web is the total of all filaments, walls, and clusters interconnected by invisible threads of dark matter. It's the largest pattern in nature, spanning the entirety of the observable universe. Imagine a vast 3D spider web where the silk is made of dark matter and gas, and the dewdrops at the intersections are entire superclusters of galaxies. This web defines the large-scale structure of reality. It isn't just an abstract concept. Astronomers have recently begun to imagine the faint glow of the hydrogen gas that makes up these filaments. The cosmic web is the ultimate architecture, the skeletal system of the universe that determines where galaxies are born, how they move, and where they will eventually die. 1. The Observable Universe. At the number 1 spot, we reach the final boundary: the observable universe itself. While we often think of the universe as a place, in astronomical terms, the observable universe is a specific structure, a sphere centered on the observer, Earth, that encompasses everything light has had time to reach us from since the beginning of time. It spans 93 billion light-years in diameter. This is the container of all reality, the ultimate structure that houses every star, every void, and every giant wall we've discussed. It's limited by the speed of light and the age of the cosmos. Beyond its horizon, there are structures we will never see, and galaxies we can never reach. The observable universe is the testament to the scale of existence, a structure that's constantly expanding as light from more distant objects finally reaches our telescopes. It's the beginning and the end of our map, the final frontier of human knowledge. Standing at the edge of a 93 billion light-year sphere, it's easy to feel insignificant. We began with the Tarantula Nebula that only spans a few hundred light-years, and ended with structures so large that they challenge the very laws of physics. Thank you guys so much for joining me on this journey across the universe. If you want to see how we compare to the stars, check out our video on the 25 biggest human-made structures right here. Nope, here. Don't know why I pointed down. It's also in the description, but I'll see you in the next one. I'm insignificant, he screamed at the sky. No, what's the Calvin and Hobbes one? Damn it. I'm significant, he screamed into the void. You know what I mean.